Hello, today we're going to discuss 5.3 compound interest. This is the application of exponential functions in economics. Suppose you have $1,000 and you want to deposit it in your account in the bank. How do you calculate the interest? It turns out the formula is A equals P times 1 plus R of M to the M times T, where A is the cumulative amount at the end of T years in your account, including the deposit and the interest. P is the principal or the amount you deposit. R is the nominal interest rate per year given by the bank. M is the number of conversion periods per year. That's the number of times the interest is calculated per year. T is the term or number of years. This formula essentially tells that the interest itself creates interest. So let's do an example. Find the accumulated amount after 3 years if $1,000 is invested at 8% per year, compounded A annually, B semi-annually, C quarterly, D monthly, and E daily. So from A to E, we just increase the number of compounding or calculation per year, and we should expect more money. So just plug in the numbers in the formula, and in part A we get a P equal to 1,000, R equals 8%, which is 0.08, M equals 1, compound annually, T equals 3. So A equals 1,000 times 1 plus 0.08 over 1 to the 1 times 3, and we get $1,259.71. In part B, interest compounded the same annually, so M equals 2. A equals 1,000 times 1 plus 0.08 over 2 to the 2 times 3, and we get the $1,265.32. Part C, the interest is compounded the quarterly, so M equals 4. A equals 1,000 times 1 plus 0.08 over 4 to the 4 times 3, and we got the $1,268.24. Part D, interest compounded monthly, so M equals 12. A equals 1,000 times 1 plus 0.08 over 12 to the 12 times 3, and we get the $1,270.24. In part E, the interest is compounded daily, so M equals 365. So A equals 1,000 times 1 plus 0.08 over 365 to the 365 times 3, and we get the $1,271.22. So you can see from A to E, as we increase the number of compounding per year, the total amount increases or the interest increases. But if we compare D and E from monthly compounding to daily compounding, we only get $1 extra. So that's why most banks compound the interest monthly instead of daily. Let's do another example. This time we need to find the number of years required. How long will it take $10,000 to grow to $15,000 if the investment earns an interest rate of 12% per year, compounded quarterly? So A equals 15,000, P equals 10,000, R equals 12% of 0.12, M equals 4. So that's compounding quarterly. So plugging those numbers in the formula, we get 15,000 equals 10,000 times 1 plus 0.12 over 4 to the 4t. And simplify the equation, we get 1.5 equals 1.03 to the 4t. And to solve for t from this equation, we need to take the logarithm. So let's just take the natural log on both sides. We get ln 1.5 equals ln 1.03 to the 4t. Using the properties of logarithms, we can put the 40 in the exponent on the right to the front of the logarithm. So we get the ln 1.5 equals 40 times ln 1.03, and we get t equals ln 1.5 over 4 ln 1.03, and we got 3.43. That's about 3.5 years. There are a few more formulas in this section, and the first formula is called effective rate of interest. We know the interest is compounded multiple times per year, but if you consider this interest coming from one-time compounding, then we have so-called effective rate of interest, and we use R effective to denote it. So we can write A equals P times 1 plus R effective, and say that equal to P times 1 plus R over M to the MT. We can easily solve for R effective to be 1 plus R over M to the MT minus 1. And another formula is called present value. That means if you want to get some money in the future, then how much do you need to deposit it now? So we use the formula A equals P times 1 plus R over M to the MT and divide the equation on both sides by the factor of 1 plus R over M to the MT. We get P equals A times 1 plus R over M to the negative MT. And the last formula is called continuous compounding of interest. So if you compound the interest every moment, then the formula will become A equals P times e to the RT. So this is the end of this section.